Okay, so welcome everyone. It's a pleasure to have you here with us almost 2 years after our last meetup in person. We're very delighted to have with us Mark Seemann, who is here in Athens on vacation. So he proposed to spend some time with us, and we're really grateful for spending his precious time with us tonight. And a quick word for our sponsors. Kaizen Gaming is providing the venue, and afterward is going to be offering us the catering afterwards. So it's a pleasure to have you here, and let's hear it from Mark.
All right. Thank you. And so Dee, please tell me if I need to speak louder, but I hope this is okay for you? Yeah. All right. So thank you all for coming, and thank you to the user group for having me. As you just heard, I'm actually here on vacation, but I asked my wife if she would allow me to come and speak to you for a couple of hours, and then she said, yeah, okay, that's fine, we can do that. I was here in Athens the last time for another user group meet, and you just told me it was in March 2017, so that's 4 years ago. And this is, by the way, my first live presentation that I've given in 2 years, and I understand this is actually the first meetup that you've had in 2 years now. So it's all very exciting, and so it's good to be here, and I hope you are happy to be around as well. So what I have in mind here is that we're going to talk a little bit about something called fractal architecture, as you can see on the slide. I'll see how much time I'll have to use on that. Maybe half an hour, something like that. I just rehearsed it this morning, and it turns out it takes a little bit longer than I actually expected it to take. But we'll go through that in a moment, and then whatever time we have left, we call this session and Ask Me Anything. So all the time that we have left, you're basically welcome to ask me anything you'd like to ask me. I can't promise that I can answer the questions, but I'd be happy to try at least. And you can ask questions about this topic or something else. It's really up to you. I'm happy to take questions. So I'm just going to jump into this topic first, and then we can see where that takes us. Fractal architecture is a thing that I'm trying to use as an explanation of a certain way of writing code. And I have a new book coming out which is called Code That Fits in Your Head, and it's coming out in November, so it's about a month from now. It's all on its way to the printers. There's no more editing to be done. I'm just waiting for the physical process to actually complete. The printer actually printing the books and shipping them out to all the bookstores and so on. And it'll be out in an electronic format as well. So if you want to read it on PDF or Kindle, that's going to be possible. But that's going to be a month from now. So the book is called Code That Fits in Your Head, and one of the many ideas, in that book is this idea about fractal architecture. It's a way to thinking about code that sort of fits in your head. Now, why is code that fits in your head? Why is that important? Robert C. Martin had this observation many years ago that he said, well, we spend much more time reading code, existing code, than we actually spend time, writing new code. So if we really want to optimize, our productivity, it's probably a good idea to try to optimize readability rather than, writability, because, if you spend so much time reading the code and so little time, writing the code, even if you half the time writing the code, you're not going to, get much of the productivity gain. Whereas if you could just shave off 10-15% of the reading part, you can actually get a lot of productivity. So the idea is to write code so that it stays readable, and fractal architecture is one of many ideas that I present in the book for doing that. And I'll explain why it's called fractal architecture in a moment. What happens when we read code? I've asked lots of people, what actually happens? What do you think happens in your brain when you're reading code? Even just simple code, like this is quite simple code actually. I would say this fits in your head. And most people agree with me when I ask them, aren't you somehow running a little simulator in your brain? Aren't you trying to figure out, okay, so what happens here? You're looking at some code here, and you basically read it from the top down, and you say, oh, here's a reservation, there's an input, we turn it into a list. No, that's not the input, that's some tables, that's a, a class property, class field, backed by property based backed by field, and things like that. So you sort of go, oh, there's there's a variable called allocation. Maybe I should keep, an eye on what happens with that particular variable. And then, some other stuff, happens. You have a for each loop here, and then down here, you will notice that there's some mutation, there's some state mutation going on where you say, oh, these two statements, they actually change the state of allocations. The first one removes the table from the allocation, the second one adds it back, but in a different form. Now, I didn't really talk about what sort of code that we're looking at here, but this is basically my usual restaurant reservation, system example. So here we are trying to we have some reservations in a restaurant system. We have some tables, how the tables are actually placed in the restaurant. Now we want to allocate the various different reservations to the various different tables in the restaurant. So this code does that. But the point is, you have some mutation going on here. So there's a variable here that changes state. And whenever you read through code, now this one is fairly unconditional. There's no if-then statements going on here. But if there were, you'd have to start keeping track of. Okay, so this particular statement added that new reservation there, but maybe it didn't, and all sorts of different things. But I would posit that this particular piece of code fits in your head because there's not a lot of stuff going on. There's basically just one thing you need to keep track of when you're trying to understand what's going on. You just need to keep track of the state of allocation because basically all the other things aren't really being changed. The reservations here, well, we loop over it, but we don't change it, and there's a lot of other things happening here, but we're not really making any other changes. So I would say this fits in our head because there's only one state change that you need to keep track of when you're running your little emulator in your brain. So we're probably quite happy by saying, well, if we have some code and there's one piece of information that could change state that we need to keep track of in our head, that's fine. What if there's two things we need to keep track of in our head? Would that be okay as well? Does that fit in our head? And it probably does. It's two things that we need to keep track of. It doesn't sound too bad. We can do that. What about three? What about four? When does it become difficult to keep track of all the different things? And here's an idea. There's quite a famous study in experimental psychology going back from 1956 by someone named Miller. I can't remember his first name. But you've probably heard this phrase, the magical number 7 plus minus 2. And basically what this experiment tells us is that, in our brains we can keep track, in our short-term memory, we can keep track of about 7 different things at the same time. And if we try to keep track of much more than 7 things, we can't really do that. The human brain just can't really keep track of more things than 7 plus minus 2. So between 5 and 9. The exact number is not really important, but it's that order of magnitude. And just to be clear, we're not talking about long-term memory here because we have other. This is just a model of how the brain works, and no one actually knows how the brain works. But this is a model for how the brain works, and we can think about short-term and long-term memory. In that model, short-term memory fits around 7 things. So the idea is that if you can somehow stay within 7 things that happens at the same time that you have to keep track of in order to understand the code is going to fit into your short-term memory, and it's going to make it much easier to watch. If you encounter some new code you haven't seen before, if at most 7 things is going on in that code, it's probably going to be a lot easier to understand than if 20 or 30 things are going on at the same time. So that's basically the idea. So in a nutshell, what I would propose that you do, and I've been doing for a long time, is to say, well, whenever I have a little piece of code, a method or whatever, it shouldn't be dealing with more than 7 things that's going on, and that includes all sorts of if you have global variables, which you really should not have, but then that counts as a thing. So you should have not very many global variables. The ideal number of global variables is 0, but still. Class fields that are in scope counts as something you might want to count. Input, variables and so on. We'll look at some examples as we go along. Now, I do know I'm just going to start a little bit. I think I'm going to scale this down a little bit. I'm going to start a little animation while I keep talking. So I'm just going to keep talking, and I'm going to explain what this animation does in a moment. But I'm just going to let it run for now already. Now, I do realize that in anything else than a toy example, there's going to be more than 7 things that you need to keep track of in a real code base. A real code base needs to have, not 7 things going on, but there are, probably 700 details that you need to, make sure that everything works in an application, or 7,000, or something like that. A vastly larger number of things. So what I've tried to do with this animation here is that instead of just having 7 things, if you imagine each of those circles or each of those blobs, if you will, if that's just a thing that somehow needs to be addressed by your code base, it could be all sorts of things. It could be details in business logic. It could be how you read and write to the database. How you render the user interface, how you log, all sorts of different concerns. Each might, these are all details. This is basically all the variables you might have in the system, or there are other ways to calculate, complexity in the system. So this animation, basically what it does, it just keeps on adding more of those circles on the screen. They actually pop into existence just at the outside in invisible frame around the actual animation. But it just keeps on adding those things, and you can think of each of those things as being, symbolizing something you need to deal with in a code base. And what you may also have noticed is that these things, these blobs, these chunks, they sort of try to self-organize, so that they, at the beginning when there wasn't a lot of them, they were trying to sort of keep the distance to each other, so that they were trying to regularly space each other out, so that they would be keeping maximum distance to each other. But you'll notice what happens when we just keep adding more and more stuff to things. This really has nothing to do with programming, but I'm trying to make a point about how I visualize things. So what you see starts happening here now, they're bunched together, and they sort of start to smash or mash each other together in something that looks quite regular. So as you'll notice here, it starts to look like a regular hexagonal grid, and that's just basically what happens if you start to put a lot of flexible things together and smash them together into smaller and smaller space. They self-organize if they have if they can move around. They self-organize into something that looks like a regular hexagonal grid. And this one is never going to be completely regular because there's a little bit of randomness going on, and there's finite sizes and so on. But if you imagine that you had an infinitely large grid and infinitely many cells, it would actually be a regular hexagonal grid. So the point of this is just that what we can do is we can say, okay, so this could hypothetically or metaphorically speaking, symbolize all the things that you need to deal with in a code base, which is vastly more than 7 things. And we've known for decades that one of the ways that we deal with a code base where lots of things are going on is that we can't, the brain can't deal with all of them all at once, so we have to decompose the system. That's nothing new there. We've been doing that for decades. So one of the things we could try to do is we could say, well, why don't we just take each, we'll say, well, regardless of the level of granularity or the level of abstraction we're looking at, we can't have more than 7 things going on at the same time. So we're sort of going to take 7 out and make a shape out of that. So that's why I had this little animation going. So I'm going to switch back here. So instead of just organizing those numbers in more or less at random, let's pick up, we'll just take out 7 cells. And I'm going to let this shape this figure, this is going to represent our short-term memory because there are 7 cells, and you can think of each of them as a sort of like a memory slot where we can put some sort of information. That's a chunk, as we call it, a piece of information that fits in our short-term memory, and we have at most 7 of those at our disposal. And it's just, the reason why I showed you this grid and how it evolves before is just to give you an idea about why am I actually using this particular shape, and that's the reason. It doesn't really matter too much, but I just think it's a fun way to illustrate things. Okay, so if we want to decompose our application, we could say, well, at a very abstract level, if we look at the entry point of our application, there shouldn't be more than 7 things going on. But then we can zoom in. If we want to learn more about particular details of the code base, we might be able to zoom in on just one of those things. And then, whenever we look at that code, there should again be just, at most 7 things going on. So this is sort of like a self-similar structure. I'm going to show you some examples in a moment. Oh yeah, thank you. Great. So for example, we might, in one of those things, we might find one cell is just represented by a thing, and from the outside, we might just think of this as the create method. And then if you want to know what the create method looks like, well, we can go and look at the code there. Now, this is example code from the book. What I've tried to do in the book Code That Fits in Your Head is that I've tried to provide a simple example code base that goes all the way through the book and provides a fairly realistic code base that is, well, it's still a toy example code base in the sense that it is an example code base, but it's actually fairly realistic in the sense that it has complicated business logic. It stores data in SQL Server, it logs, it does security, and so on. So it actually has, and it has lots of unit tests. So it's a fairly realistic, yet still, it's not a simple application, but it's not a super complicated one either. So all the code that we're looking at is from that code base. This one is from a repository that creates a new row in the database. So not that I want to walk through all the stuff that happens here. It's fairly straightforward. It's quite pedestrian, actually. But the point is, does this, we can try to ask ourselves, does this fit in our heads? Well, are there at most 7 things going on here? And the first question we should ask ourselves is, okay, so how do we measure, what's going on? How many things are going on here? And there's not one way of doing that. Sometimes I like to use a measurement called cyclomatic complexity. That's one way you can do that. But for this slide deck, I actually want to do another thing. I just want to count the variables that are involved, because the variables are often the things that you need to keep track of when you're trying to understand a piece of code you've never seen before. Because those are the things that might change state. And that's what taxes our memory. So we can try to count the variables, and we'll figure out that there's actually 6 of them. And a lot of them are not really very interesting, because if you look at the first one here, restaurant ID, for example, that's just an integer. It's an immutable value. That's not going to change state. So we basically ignore the restaurant ID in terms of trying to understand or trying to keep track of all the state that's going to happen when this method runs. We can say, yeah, that's not really of our concern. So maybe we need to think about, okay, what happens if it's positive or negative and so on. But it actually doesn't matter in this particular case. But there's only 6 things going on here. So this, according to that particular way of quantifying, how much stuff is going on, this fits in our brain. I'm not saying this is scientific. It's just a way of trying to think about things and thinking about, thresholds and limits and so on. I find that even though it's not scientific, this actually works out pretty well in practice. I've used this way of thinking for a long time. I've taught it to my clients as well. And it's a fairly efficient way of trying to keep the complexity down. To just do some simple counting of how much stuff is going on. What's the cyclomatic complexity? We don't have that here, but so that's one thing to notice about this particular method. Another thing to notice about this method is that this is the most detailed level you can ever get in a user code base, because all the stuff that's actually being invoked here, the SQL connection, the SQL command, all the methods on those objects, that's .NET framework stuff. That's part of the ADO.NET API. So you can't really say, well, gee, I wonder what happens inside the added value method. Well, you can't go and look at that, and unless you can disassemble the .NET framework code, that's not available to you. You sort of just have to, trust that you understand what's happening here. So you can't really look at more details. This is as detailed as you can look at the user code, unless you want to disassemble the .NET code itself. So this is, if you're thinking about, looking at code as looking at various levels of zoom, where sometimes you look at the code base from a distance, sometimes you look at it very, up close. This is as up close as you can get. You can't get more detail than this. So that's one way of thinking about things. So we could take those six, variables, those six things that I just mentioned here, and we can write them out in a list. But we could also take and plot them into this hedge flower thing that I just talked about. And because there are only six things, going on, and we actually have seven, slots, we can assign each of those memory slots one of those things, and it fits in our head because we actually still have one free. So I'm fairly happy about this method because according to that heuristic, at least, that fits in my head. I think I can manage with that. And then my short-term memory, I don't have to use my long-term memory in order to reason about code as long as it's structured as simply as this is. So what happens if we zoom out, though? So right now we've zoomed into the most detailed level of granularity that we can, but what happens if we zoom out? So this fits in our head. Tick? No? Okay. The space bar's not working. All right, so what we can do is we can zoom out, and then the idea with fractal architecture is to say, well, if we, for example, look at the create method that we just looked at and say, okay, so what other code is going to call that method? That means we can now zoom out and we can look at the code that is calling the create method, and that's going to give us another view of the code and another level of granularity. So basically, we can keep on zooming out of the application and trying to understand, higher level structures in the application itself. And the farthest out that you can actually zoom is going to be the entry point of the application. So, for example, if you've never seen this code base before, which I suppose you haven't, the static void main is probably a good place to start because you say, okay, so I have no idea how this code base is organized, but I know that the .NET application needs to have a main method. This is .NET Core, it always needs to have a main method. So you look at this, and if you've ever seen some ASP.NET Core code before, this is absolutely just boilerplate code. Everything interesting happens in the startup method. There's nothing interesting actually going on here. Still, we can try to just count all the things that are happening here. There's only 3 things, so that fits in our brain. That's very clear. But we probably want to have a look at the startup class there because that's where interesting things happen. So you notice again, we zoom in, we look at the code a little bit more up close, and then we start to look at, okay, so what does the startup class look like? And this is just a public API, and by convention, it has a configure and a configure services method. It also has this constructor, and again, there's a conventions here, so that if your constructor, for example, takes an configuration value, the ASP.NET Framework is just going to give you an iConfiguration object that contains all the configuration from the config files and stuff like that. So that's just by convention. So this is just something you have to know about ASP.NET and the way that it works. But it's very straightforward. Now, again, you can take those 3 things and say, well, that's easy enough to understand. That sort of fits in my head because there's not a lot of things that I need to understand. And if you want to know something about the configure services method, now you go and navigate to that, and then you have a look at what's actually going on in there. And the whole point of this whole fractal architecture code that fits in your head is that when you zoom in on this detail, when you start looking at this particular method, you shouldn't care about the other methods in the system. There was also a method called configure, not configure services, and the way you should write those methods is they should be independent of each other. They should be unrelated to each other so that when you look at one, you don't have to know what happens in the other one. Because if you do, there's more stuff you need to keep track of in your head, and then you have a budget of 7, and that's really not a lot. So you sort of need to be very explicit about only putting things on the screen that your brain actually needs to know about. So again, we can count the variables, and that's really not very interesting here, so I'm going to skip fairly easily over that. But what we can also do is we can see down towards the bottom here, we have a list of methods calls that calls into various different helpers. So if you read the names of those helper methods here, they'll give you a hint of where you can go and look for other things. So for example, if you're interested in learning in this particular code base, if you want to know about security, for example, you have a method call here that says configure authorization. And that's probably a good bet to go and look at that particular method if you want to know something about, okay, so how does security actually work in this particular code base? You probably navigate to configure authorization to learn about how that works. On the other hand, if you want to know about how data persistence works, there's a thing here called configure configure repository. And if you know something about the repository pattern, you probably think to yourself, well, that's probably where the data access stuff is somehow being defined. So maybe you'd like to go and navigate to that method and learn about the repository and how that's set up. And again, the point is, when you do that, if you navigate to the configure repository method, what happens inside the configure authorization method should be completely irrelevant. So when you look at the configure repository method, only the stuff that actually happens inside the configure repository method should be what you need to know. And if you can keep the amount of moving parts inside of that method at 7 or less, then it fits in your head. Now, I'm not sure, I don't think the slide deck is actually going to navigate to configure repository, but we can do that afterwards if you're interested in watching that. But basically, the idea is when you navigate to one of those 6 methods there, you again zoom in on another level of abstraction in the code base. But again, if you follow this principle of that there only ought to be 7 things going on, because that's the constraint that the human brain has, then you can keep code readable and understandable at all sorts of different levels. So you can zoom in and you can zoom out, and you'll notice that we keep on having this same structure because that's the structure of the human short-term memory, and that's actually quite a hard limit on our productivity. So here's the entry point again, mapped out into the Higgs flower. And then if you want to know about various things, for example, about the startup method, you zoom in on that. If you want to know about configure services, again, you zoom in on that. So I'm just trying to illustrate that you can zoom in and out at will, and as long as the code fits in your head, you should be able to always plot the complexity of each of the levels of abstraction into the same sort of structure, this Higgs flower here. So this starts to explain why I'm actually calling this fractal architecture, because even though you only have 7 things that happens, these are 7 things that happens at that particular level of abstraction. If you remember the configure services method that I showed you just before, there were only 7 things going on, or 6 things going on, but they were at quite a high level of abstraction. And you need to sort of look further if you want to know about the details. And ultimately, you might end up at one of the details like the create method that I showed you, where you can't really look closer because there's no more user code than that. So each of those 7 cells here might actually, again, if you structure your code like this, each of those 7 cells will probably contain another 7 cells, so that if you zoom into that, there's 7 more things going on, but then you can forget about all the other ones. And then if you zoom in on that, there's 7 more, and you can basically keep on going there. When we render fractals, we sooner or later have to stop rendering, because otherwise it's just going to be one big smush of things. So we can think of the code that we wrote as being there's a level where we stop rendering because the code has reached maximum granularity. That's where you have no more user code, but you're calling into the .NET framework code instead. And if you don't think this is a fractal as you'd expected them to be, if you were expecting some magical set or something like this, I want to point out another fractal just to give you an idea about the similarity. This is called a cock snowflake, and it's basically following the same principles as the hexagon of flowers that I just showed you. And this is a very well-known mathematical fractal. So I think I'm fairly much in the clear by calling those hex flowers fractals as well. So that's basically the idea. Write code that fits in your head. One of the ways you can do that is by making sure that regardless of the level of abstraction in your code base, at most 7 things ought to be going on. Right. So that's part of the book. This is actually what the book looks like. It's it has lots of other, as it says, heuristics for software engineering. It's a lot about how do you write code that fits in your head so that you can minimize the amount of time you need to read the code. So make the code more readable should probably make it more productive because that's where you actually spend most of the time. So that's out in about a month from now on. So yeah, that's about half an hour. That's not too bad. I don't have more slides for you, but I'm very happy to take questions now. What I can tell you, one option is that I actually did bring the entire code base here. Maybe I should probably zoom in here if we just increase the font size if we need to look at that. But I did bring all the code base here, so if you're interested in some of the details, I will increase the font size and we can look at that. But otherwise, I'm happy to answer just about any sort of question about this or about something completely different. So should we start with questions, anyone? Yes, please.
At some point, at the beginning, you mentioned something on how to define doing things, like that.
Yeah.
Then you mentioned that we can keep track of the different variables or parameters. But when you configure the configure services function, you have the count as things the different.
There's different method calls.
Yeah.
Yeah.
So can you offer a bit of a more generic?
Now that's a fair question. Okay, so let's just let's increase the font size here. So let's start with the program. Let's see if we can find it then. Is that better? All right. Okay, so we'll navigate to the startup. I'm probably gonna need to. Okay, no, it actually remembers the thing. And then you said let's look at configure services, which is down here. Yeah. So what you said was that the first thing I did was I counted the variables, and it's basically something about the URL signing key. That's one, and then there's 2 actually called opts, and I ended up counting 6 variables, and that's just one way of doing that. But then you point out that so I actually cheated a little bit, and you actually caught me cheating. But then you said, well, I actually ended up counting those 6 things instead, and saying that's sort of things that that we need to keep track of. Okay, so I admit that I did cheat a little bit in the sense that after I think I only cheated a little bit, but basically my point here was this code. I still think this code fits in our head in the sense that there are no more than 6 things actually happening. But the fact that I actually ended up counting those method calls down here was a little bit of a cheat because I wanted to make a point about how to navigate and look at further details in the code base. So that's why I did that. Now, to be fair to myself, I'm not insisting that there's only one way to measure complexity. This thing about counting the number of variables that are being used within a method, that's one way of doing it. I'm also often very happy to look at cyclomatic complexity because that's sometimes a better measure of complexity than just counting the variables. So sometimes I do that rather than count the variables. So you say that I don't use just one measurement. I'm just trying to give people ideas about what to look for in terms of is this method okay, or is it getting too complicated? And instead of particularly if you're working in a team and you're a little bit in doubt of okay, so I'm gonna add 3 more lines of code, and I'm gonna add if else branch here, and I'm gonna bring in 2 more variables in scope. should I refactor? And then maybe your colleague will say, nah, it's okay, it doesn't change, it doesn't increase the complexity of the methods that much because you're already at a certain level of complexity already. And then you say, well, okay, but that's only one more if branch, or it's just two more variables, or something like that. So the point here is not so much that you have to use one measurement over the other one. It's more that if you are beginning to feel a little bit uneasy about the code, it can be very nice to have a language for, why does this begin to feel not as good as it could do. So this could give you a language where you could say, if you have a discussion with your colleagues, you could say, yeah, it's true that I'm only adding 2 more variables, but we already had 7 variables, and now we have 9, and that begins to hit the ceiling of what any human brain can actually keep track of. And I think we're that close to making the code unreadable that we should probably split things apart and refactor them. So that's actually more the point that I have. But I honestly admit that I did cheat a little bit by counting those things down here because I wanted to talk about how to navigate to other parts of the system. So we could actually arbitrarily take this block of code and hide them behind one single, helper method, and then we could say that's only one thing. So and it probably wouldn't make much. Yeah, I don't think it would make this code more or less readable actually. So yeah, so I cheated a little bit. I hope that's
it wasn't a aha moment.
No.
I want to tell you but I mean the bottom part it's like the kind of a block. It does the same thing for different services.
Yeah.
So in my mind, sometimes when I have something like this, I don't mind even if I have, let's say, 20 such functions.
No, and I agree. Yeah, you could definitely have that. I think I kept some of that because, I'm not perfect either. Sometimes I was just say, hey, this is good enough, and then I just let it be. But maybe I should have put that. But I think it's a good question. Yes.
I guess we can say we need to have things on the same level of detail, for example, in the same method. So you don't have like very detailed stuff and very high level stuff in the same method because that's increasing the cognitive load, I would say. If you have things in the same level of abstraction, like such methods on the bottom there, I guess it's...
also what things together all the time makes more difficult.
No, and I agree. Having things at the same level of abstraction is, a good old advice. And I definitely actually, didn't do that here because, getting this URL signing key, this is quite low level. And I should probably have, written a helper method that did that. That's a little bit of a different discussion because it doesn't really have much to do with, how many things are being used. But if we take on that idea that you just mentioned, I completely agree that I should have done that, but I didn't. So again, an example where I wrote a lot of code for this book and it's not all perfect. There's definitely still room for improvement, and I absolutely admit that up front. So good point there. Yes. I hope that answered your question. Well enough. Yes.
Sometimes, in order to keep the control base in your head and try to understand things as they go, it's important also to keep in your mind the stuff that are not there.
Yes.
So, for example, in the repository create method that you showed earlier, there's some stuff that somebody might expect to find there, but they're valid. And that by virtue will increase the count over 7 for every method. Not right. So I understand that having a style that it is across the code base can save you because you know that by that style you know what to expect to have. But it's not a natural in large code bases in large systems. The style to change over time, start to get amiss. So how do you handle that?
Yeah, so no, I completely agree that if you have an existing code base, it's probably not written with this idea in mind. And at this point, we're basically into the territory that Michael Feathers describes in his book, writing working effectively with legacy code. We need to figure out a way to get, away from the harmful parts of the legacy code base into something that looks better. And that's a completely different discussion. But you're absolutely right that if you have global variables, if you have something that in the dependency injection book that I wrote many years ago, I have something called an ambient context, which I did describe because lots of things in the .NET framework actually works that way. Like you have thread.current thread, that's an ambient context. You have culture.current culture, that's an ambient context. All of those things that are sort of just, even datetime.now, which is a horrible API design, but it's in the framework, so it's pretty hard to get rid of. But it's true. Whenever you're using datetime.now, for example, that's an example of what you're talking about. It's not, it's not an input argument into the method. It's not a class field. It's not something that was injected into the system, but it's still there, and we may have to think of that as one of the things that are actually going on, because it may actually tax our brains. So it's true. So one of the things that I really like to ask people to do is to say, well, you have to get rid of all of those ambient things, all the global variables, all the singletons that can change state. I don't mind singletons that can't change state, that's a different thing. But all the singletons that are mutable, all other sorts of global variables, all sorts of ambient contexts, those are adding up to the budget of 7, just as you said, and you need to somehow be able to make those dependencies explicit. So one of the things that I've done in this code base, for example, that I typically do is that something like the system time, for example. Let's see. So that I actually have this thing called configure clock, and the reason for that is particularly because the time and the way that time passes is again one of those ambient contexts, and they do influence how the system actually behaves. So I typically pull that out into an explicit abstraction. So in this case, I just call it iClock. I'm actually using the ASP.NET dependency injection system here for various reasons. But I defined this thing called iClock that just gives me the current date time. And it's completely just a wrapper within datetime.now, but that means whenever I need the current date and time, I now have an explicit dependency, so we can look at something like where do we need that. We can see if we can navigate to that. I have, for example, something called a Reservations Controller here that needs to check whether whether the time is whether we're trying to make a reservation in the past or not. So instead of using just datetime.now, we're actually going to use, let's see if we can find where it's referenced. Let's see. We need to find this one, the clock, and then we can see it's sitting down there. So this also makes things a lot more. This has the nice side effect of making things easier to unit test, because now you can provide a deterministic source of time into the system instead of relying on the plot itself. I hope that answers your question. Yes?
And so this fractal architecture applies mostly in imperative language or in functional languages as well?
You will probably discover that one of the, I would say it applies in both paradigms, but you'll probably discover that when you try to apply the style of thinking and architecture, functional programming gives you lots of very useful techniques of actually doing this. Because what you can do with functional programming, or what you're supposed to do with functional programming, in FP, you want functions to be pure, referentially transparent, and just for the, you're nodding, but just for the, if there's anyone who hasn't heard about this. Pure functions need to be deterministic. That means they should always return the same input for the same. They should also always return the same output for the same input arguments, and they can have no side effects. So calling a function cannot send an email, it can't write down to the disk or things like that. So this this idea of a referentially transparent function has this again sort of side effect that everything you need in order to make the function return one of very different desired outputs needs to be available via the function arguments. So once you figure out how to write pure functions, you have this nice effect of doing that everything arrives via function arguments, and now it becomes more or less a question of controlling the number of arguments that a function can take, in the sense that well, technically you can write a function that takes 20 arguments, but that means that there are 20 things that influence how the function behaves, which is probably not a good design anyway. But I'm not saying it's always that it only works for FP. The way that I try to write this example code base is that I've used this style called functional core imperative shell. So the idea is that if we look at the way that I've implemented all the business logic in this code base, they're actually pure functions. But then, if we look at something like this, this is the shell. Or let's go up a little bit. We're looking at a controller here, and there's a post method, for example. So this is a post method on a controller, and the controller implements a REST API. And at this point, then the real world is not referentially transparent. It's as impure and messy and non-deterministic as anything. So at the shell of the application, at the HTTP, this is an HTTP post, for example. Well, there will be non-deterministic behavior and side effects and all sorts of things. So I kept that imperative. So there are things going on here that actually does change state. But then it calls into a lot of other things that don't change state, that are actually pure functions. So for example, here it calls a helper method that actually tries to figure out whether to accept a given reservation. That's just a helper method, so that's still on the controller itself. I think it's just sitting down here, actually. It's just sitting down below here. So I could just continue things, actually. This is still imperative. There's really not very much going on there. But then if we go in and look at, so there's this one method call here where we call into this thing called matrix will accept. And it looks just like one method call, but if we navigate to it, we'll figure out that this, first of all, this is not an injected dependency. This is an actual method. This is a concrete method. It's actually a function. Well, you can't really see that here, but it's not hidden behind an interface. This is just a concrete method call. But this thing then actually has quite a bit of complexity because it needs to make all sorts of different decisions. So there's quite a little bit of input validation, and then it looks like 4 or 5 lines of code there. But that's again because we're calling into other functions that have more deterministic, non-side effective behavior like that. So that's actually quite a bit of things going on. I do, I've been doing functional programming for the last 10 years, so I do gravitate towards that. But it's not that I don't see this idea about fractal architecture as being only about FP, but it really leads, it fits very well with the functional core imperative shell style. That's probably the shortest answer. I hope that gives you an answer there. Yeah. Okay. Anyone else? Yes?
Hi. Thank you for the presentation, first of all. I was wondering if this way, both with the fractal architecture and by grounding technological complexity for functions, we are in fact improving functions as units, but maybe we are making the code base more difficult to navigate through by exchanging breadth for depth, which in my experience, following up a code base through function calls deeper and deeper, and then having to have this all this cognitive burden as you go through is much harder than reading a function that is badly written. So I'm wondering if we're exchanging one demo for the other.
Yeah. What if I said, maybe you're right? None of the things that I say here, I don't present this as a universal truth. It's basically just some ideas, and it's a way where I try to describe what I have observed works for me. And so it works for me. It's worked for I have various different clients that I work with writing new code or improving their existing code base, and I've noticed over the years that there are various different ways where sometimes I try to explain to other people certain ways of doing things, and I can feel half the times what I try to explain doesn't really stick with them, and then there are other ways where I can explain things in a certain way, and then people say, oh, that actually makes a lot of sense. So what I do here is I'm trying to sort of, whenever people say, oh, that makes a lot of sense, I say, this is an explanation I'm going to use again the next time. So that's basically what I'm doing here. So first of all, I'm not claiming that this is, you must do it this way, and if you don't do it this way, this is not going to work for you. That's not what I'm saying at all. But I just noticed that the way that I try to explain these things are what typically tends to make sense to other people. And that said, and you may be right, and you may be exchanging one problem for another one. It hasn't really been my experience that that's the case, but I can't guarantee you that that's not going to be the case. But at least one thing so we talked a little bit about functional programming and or at least referential transparency and things like that. And one thing I've found is that sometimes duplication, when you do pure functions, duplication tends to be a little less dangerous because there might still be edge cases. If what often happens when you said you exchange depth for breadth, was that what you said? That's a very nice way of putting it. I hadn't thought about that. So, but I think what often happens when you have that breadth is that there might be lots of methods or lots of functions that are already implemented, but you don't know that they're there because one of your colleagues actually wrote that function and you didn't know it. I'm working in such a code base at the moment because I'm helping one of my clients who wrote an F# code base, and he's been writing that F# code base for the last 5 years. And now he got so much stuff to do that he asked me whether I could come and help him with some pull requests. And what often happens is, I send him a pull request, and I've just done some stuff, because I just wrote the code that did some input validation or whatever. And then he says to me, I send a pull request, and then he says to me, well, you don't have to re-implement that because it's already there. And then I basically go, okay, yeah, but then I'm going to use the one that's already there. But I didn't know because of the breadth, I didn't discover it. So I'd probably say if you just do that, if you just exchange the depth for the breadth, and you do no more, you might actually just be exchanging one for the other. But I then found out, from this example that I just told you, that if you have reviews, which is also something I write about in the book, you should definitely have code reviews. Then you can catch a lot of those things, because then maybe you don't know, that a piece of code is already there, but then someone else can help you and say, hey, have you thought about using this thing that's already in our code base over there? And then you probably say, oh, I didn't know about that, but I'm going to do that then. So I think this technique is not going to stand on itself. You need to combine it with other practices as well. And then, so again, the book is basically just a catalog of ideas, and this is one of the ideas that you can use. And my intent with the book is not that you should use all the ideas in the book. My intent is to give you ideas, and then you can say, oh, there are 20 ideas in the book of how many there are. And if you just go and say, well, these 4 ideas I like, I'm going to do those, then I hope that I've improved your life. But again, I think your criticism is valid. I think we can get around it by combining it with some other techniques, like doing code reviews or pull request reviews or things like that. But otherwise, yeah, that's probably a risk.
So I'd like to have as well, when you exchange depth and breadth, it's kind of easier to organize things. will show that in the presentation. Takes a second and then you zoom in.
Yeah.
It's kind of presented. So if you explain very quickly the concept of trying to categorize what each branch actually does, that potentially could make things easier to deal with.
Possibly, yeah. But then again, now you're I think you're right if you're assuming that the people who organized the things at the first, they actually did the right thing.
Yes.
And so people actually often ask me about, okay, so how should I organize things? How should I organize, for example, the file system of my code base? And few people actually like the answer I give them, because I'll show you how this code base is organized. Let's see. Okay, so here's the Solution Explorer, and I know it's very small, but it doesn't really matter. But you'll notice that I'm not a fan of putting things in folders. And this is actually quite deliberate. I do have a few folders here, so you actually, if you look at the top here, I actually have, well, properties is just Visual Studio that's doing one. I have one folder that I created for this application. You can't read it, but it's just options. And it's because the .NET Core and the way that it does, configuration system, it wants you to write, classes for, JSON configuration in a very specific way. And it's a way, where you have to write everything as mutable details, and I really don't like to do that otherwise, but you have to do it there. So I put it in a folder, but, this is what Eric Evans would call a, what does he call it? He calls it an anti-corruption layer. So I just, I hid all the ugliness there, but otherwise I don't really have any folders. I just have, straight files here. And I tend to do that even with code bases that are much bigger than this one. And it's not because I don't want to organize things. It's more because, since you're mentioning it, and thank you for bringing that to my attention, the problem with files is that you only get one shot at organizing things. If you start to creating a particular file, folder structure, you're sort of stuck with that. And I've often seen people doing, for example, something like this, which uses the MVC model, the model view controller model. I've seen people having one folder called models, another one called controllers, and another one called model view, and one called views. Then, and that's one way of organizing the code base, and that means if you're looking for controllers and you want to know something about controllers, that's going to make your life easier. But in this code base, for example, if you want to know something about the calendar system, there's, this is a restaurant reservation system, and it has this calendar where you can, look at various different restaurants and see how many, remaining seats do they have on various different dates. That's a feature, and there's a calendar controller, but there's also some domain logic that, does the calculation and so on. So if you did, a folder that's called controllers and one called view and another folder called models, you'll have to search for how a feature is implemented. It's going to be spread across various different file folders. So it's really hard to get file, organizing things in a file structure so that it's always right. So I'm basically just defaulting to, I've given up on that, solving that problem. I'm just saying, well, it's just going to be in a flat list. And that's basically not how I navigate my code base. So you notice when I was navigating around things, as I was going around here, what I usually do is I find something like the allocate method here, and I click F12, and then I go to that one, and then I have a look at that one. So where it's actually placed over here is really not something that I try to ignore that. So usually my Visual Studio is probably going to look like this, where I have my Test Explorer over here, and I don't really care where my files are. Which doesn't mean I don't not care at all, but it's just not. It's not my main organizing principle. I really think if this is a thing that I would wish that IDEs would start to use. I would really like to see an IDE that allowed me to organize my code artifacts in other ways than files. So that, for example, you could say, well, it'd be very nice to have, just at the top of a file or something, if you could, if you imagine that you could just put some sort of, an annotation or something where you could say, well, this is a, if we go back to the controller, for example, So here we have this reservation controller. It'd be very nice if we could somehow say, well, this is a controller, but it's also, so we annotate it with the word controller, but we also annotate it with the word reservation because it's part of the reservations feature. And then we would have this sort of more, almost like a database of things, a graph of things instead of just, a tree of things, a hierarchy of things. But that's another thing. I've never seen an IDE that can do that. Not a commercial one anyway. But that was really. I'm sorry. I may have ran off on a complete tangent here. So did I address your comment?
No, actually, I wasn't pushing. I was just adding to the conversation about this.
Okay, thank you. All right. Anyone else? Yes.
Any other non-code related stuff that you mentioned in the book or that make the code fit in your head? Like I read one of your articles about code review, for example.
Yeah.
About mixed requests or pull requests, whatever. You need to get them short. Anything that doesn't have to do with code. I mean, something and other ideas inside the book.
Yeah. Oh yeah. So you're asking if there's more than just code in the book. Yeah, there's actually a couple of chapters about processes for working. So I do have one chapter is about reviews and not only reviews, but I talk about pair programming and mock programming and doing code reviews and all sorts of things like that. So and I'm actually not taking a stance in the sense if it sounds like you follow me on Twitter as well. I do admit that I sometimes get a little bit annoyed at a certain group of agile, thought leaders who tend to insist that code reviews are bad, which I definitely don't think they are. I think code reviews are very, very valuable. But on the other hand, it doesn't mean that I think that pair programming is bad. And a lot of people, whenever I say no, code reviews are good, if I say that on Twitter, then people basically think that I'm saying pair programming is bad, which I'm actually not. I think both have value and mock programming as well. So there's a chapter on that in the book, and there's a chapter of various ideas of just how to, one is working together as a team and various ways you can organize processes. And the other one is more about, there's some things you can do for yourself and your own productivity. So I didn't want to turn the book into a self-help book, and I also didn't want to turn it into a book about project management or things like that. So so it's not that's out of scope. I consider that to be out of scope in the book. But what I did want to touch on was things like just simple things you can do in order to somehow improve your productivity, your personal productivity, and your team productivity. So I do, for example, talk about with reviews. I've noticed that if you don't have an explicit policy on doing reviews, I've tried to, I've visited teams who never did, code reviews before, and then I said to them, okay, let's try as an exercise. Everyone was just writing their own code, and they were just merging into, to master and get whenever they thought they had something that were ready, and no one ever got to see it until it was too late. So I've tried to teach those teams, okay, now instead of doing that, you're already using Git, you're probably using GitHub or something similar to that. Let's try to do pull requests and try to review each other's code. So what happens in a team like that, the first couple of weeks, people make a pull request and then no one looks at it. And then, everyone makes their own pull request and then work stops because no one looks at the pull request. And then, as a consultant, I have to go around and say, hey, can you please look at that pull request your colleague sent? And they go, okay. I say, and then they just approve it, and I say, did you look at it? No, I don't have time for that. So, I sort of have to go and tell them and try to teach people, why it's actually valuable. So one of the things I try to tell people who has to review, I say, okay, now, if you accept this pull request, that code is now your code, and I will give you the next thing that needs to be done on that code. You will be the person who has to maintain that code. Now do you want to accept it? And that gives people a complete, if it's good code, they will accept it, but that gives people another level of, okay, should I actually accept this? is that stuff we want to be, is that part of the code base? Are we okay with this? So that's one thing. So another thing that you can then start to do when you try to give people this habit of reading and doing reviews of other people's code is try to make it part of a daily routine. Lots of teams tend to have some routines. Some people still do daily stand-ups. I don't think that many teams do that, but but that was the thing 5-10 years ago. So if you still do the daily stand-up, you might, for example, just say, well, after the daily stand-up, you spend 20 minutes doing, everyone spends 20 minutes doing code reviews, pull request reviews. Or you could say, a lot of teams still go to lunch together, and you could say, well, after lunch, when you come back from lunch, you had a break anyway. You could spend the next 20 minutes, going through pull requests. So you sort of get a rhythm into the day. I do talk a little bit about things at that level, but I didn't want to. I didn't want to move into the territory where I would be interfering with, if people were doing XP or Scrum or whatever. So it's more like, again, it's an idea you can adopt if you like it, and you can leave it, if you don't like it. So there's a little bit of stuff like that in the book as well. Does that answer your question? Yeah? Okay.
Okay, I guess we have time for one more question.
Yeah, I don't have a very hard deadline, but I have a family who wants to have dinner with me tonight. But yeah, okay. So I can probably hang around for 10 more minutes.
I have one question if nobody wants to go. So we talked a lot about cognitive load and things that really get in your head, need to fit in your head regarding code. And we've seen many approaches for handling this, like for example, the onion or hexagonal or other kinds of patterns for separating things and keeping them clean. I'm not sure if you're aware of the Topologies book. The authors discuss the cognitive load in terms of intrinsic and extrinsic and germane cognitive load. I'm not sure how your approach stands against these.
It probably doesn't have. I'm aware that book exists, but I haven't read it.
Okay.
So it's probably. I hope that my book is compatible. But since I haven't read it, I can't really tell. Okay. I've noticed that one of the people that I constantly run into, discussions with on Twitter is actually one of my favorite, Twitter people at all. Dan North. I highly respect Dan North. I think he has great insights into lots of things. And then we constantly seem to argue with each other, and he's probably right and I'm wrong. I don't know. But I've also noticed that since you're asking about that, Dan tends to have a more he has a perspective on the human side of things, and I'm actually quite a nerd, so I'm very interested in the code part of it, and sometimes I forget the human part, and I tried with the answer that I just gave you, I tried to draw in a little bit of observations I've done about how what works for myself as a person instead of just a robot, if you will. But the deep insights to be had about how teams work and how what motivates teams and so on. I'm actually not very much. I'm not an expert on that. So and it's also. I wouldn't say that it doesn't interest me, but there are other things that tend to pull my interest more. So I sometimes forget about those other things. So that's not really a good answer, but it's an honest one at least. So that's probably as good as I can give you an answer to that.
Okay.
I still have some time, so we
anyone else?
Some stuff as well. Anyone else?
Okay, if nobody else has any questions.
I have one technical. How big is how can we measure how big is the pull request in terms of file?
Right. Yeah. I've never actually tried to measure that.
Because in reality, the pull request is quite large. Right. We get more than 25 CVs. Pull request is quite a lot to.
It's really difficult to put a line number on it because sometimes.
Is it us that we're doing it wrong? Like is it us we're not splitting the features correctly?
Yeah.
We're not committing correctly? What?
Yeah. Okay. So in general, large pull requests are really problematic because one of two things tend to happen, and the most common thing that happens with a large pull request is that the reviewer just gets just basically gives up on doing the review, and then he or she just approves the pull requests without really looking at it, and then the review is really worth nothing. So that's the one thing that might happen. The other thing might happen is that you get into because the pull request is very large, you get into all sorts of things that needs to be fixed on the pull request, and then the pull request is sitting there for days and sometimes weeks, and it falls further and further behind, because the rest of the repository actually is still moving forward. So at the time where every comment has been addressed, it's fallen so far behind that you now have lots of merge conflicts, and then you have lots of work needed to be done with that. So large pull requests are really problematic for those two reasons. Basically, you need to divide them into smaller things. And actually, one of the things I discuss in the book as well is this idea Martin Fowler calls, no, it's not Martin Fowler, it's Jess Humble calls feature flags. So instead of waiting until you have a full feature that you want someone to review, you write a little bit of code. It's an incomplete feature, but then you hide it behind a feature flag, and then you ask the person to review something that's just a partial implementation, and then that actually gets into master, and then you work a little bit more on it. So what I usually say is a pull request should represent half a day's of work. So it's not so much how many lines of code, but more how much work did you put into it. Because another thing, what's happening, the thing about half a day's work is that a review is not worth anything if you have to accept the pull request. Declining a pull request should be a real option. And if someone has been working for 2 weeks on some code, it's really, really difficult to reject a pull request. But on the other hand, if someone has just worked a couple of hours on something, and then you say, that's not really what I don't think that's a good idea. I think we should move in another direction instead. It's okay. It's happened to me several times the last week. I told you I work for one of my clients at the moment, and it's not even that he declined my stuff. He just started asking questions, and then I could see the way his questions went. I could say, yeah, okay. He has a point here. This is actually not very good. And then I just closed it myself. Say, yeah, no, we'll close this one without merging it and go in a different direction. And that's, we shouldn't see those 2 or 3 hours as wasted time. This is 2 or 3 hours we invested those 2 or 3 hours into learning more. We became smarter. And if the end result is that we didn't merge the code, that's okay. We got smarter, and then we write some better code afterwards. So, yeah, that's the short answer.
If the point of half a day of work is enough to put into request and no more.
Yeah. Right, that's in the book as well.
All right, so we don't want to keep Mark for much longer because he has plans for tonight. We're very grateful for this presentation, and we really enjoyed it, I guess. Mark is very kind, and he's offering a copy of his last book and some t-shirts.
So, that's the book before this one.
Yeah, before this is not printed yet. So does everybody have a number? Okay.
Can we use a letter for the raffle? Like for random protocol? Can we use a random protocol? There's a website.
Random.org. Okay. All right. So if I may say a few things about the stuff that I brought. So yeah, that's a copy of the previous book I wrote. I also brought 2 T-shirts. One which is actually a marketing T-shirt for the book, and then I brought I found a very old AutoFix T-shirt, and it probably needs washing. It's never been worn, I promise, but it's been lying around in my apartment for a long time collecting dust, so it may look a little bit dusty, but I promise no one has ever worn it. But it's old.
Okay, so
random.org.
we have 28 attendees today.
All right, so what do we do here?
We need to set the max number towards the right corner.
This one? Yep. And then you said...
Minimum 26, maximum 26.
What's a bit biased?
How much did you say?
1 to 28.
28. Okay, like this.
And let's generate. We have.
Wait.
We also have a couple of event store T-shirts. So let's go for the book first.
No. That's the main prize. That goes
Yeah.
So let's go with the auto fixture T-shirt first.
All right.
No one wants that. But still.
Okay, let's go.
Yes. All right. Are you ready? 15. 15. So is it okay for the gentleman to win the other stuff as well?
He's out of the pool now, but
He's out of the, so if we do 15 again, then it doesn't count. Okay. All right. Next one.
For the
Dependency injection T-shirt.
Are you ready? 21. And if the size doesn't fit, I can't help you with that.
Okay, let's go for the book next.
All right, ready? Here we go. 3.
Okay, we have 2 more pieces from event store.
Right.
I'd like to.
Shoot, and is it one draw for 2 t-shirts?
No.
Okay, okay. 15. I can so that fits in my head. I can actually remember the last 3 numbers. Still barely. Okay, let's try again. 3. Are you sure this is
It's supposed to be.
9.
9.
All right. And one last time.
And one last time. Number 4.
4.
All right. Thank you very much for this presentation and discussion, Mark.
Thank you for coming.
On behalf of the meetup organizers, and because we're going to thank you for for spending your time with us tonight and not going out on your vacation. We have bought some trees. We have planted some trees for you.
Ooh, thank you.
To help offset some of your environmental footprint for coming to Athens.
Yeah.
And hope you enjoy.
22 trees. 22 trees it is, yes.
All right.
Thank you.
Thank you. Once again, thanks to our sponsors for the venue and the catering, Kaizen Gaming and Upward. You can find some people from both these organizations here and find out more info about them. So hope you enjoyed it as much as we did, and we hope to see you again soon, maybe in person or remote. Who knows?
Yeah.
All right.
So, Pete, don't leave just yet. Don't leave just yet. So we're waiting for the pizza and beer. So don't leave just yet. That's the best part. I'm